Good morning to all of you. Welcome in the class of fluid mechanics and hydraulic machines. Today we are going to discuss about the fluid pressure. Let's first define the pressure. What is the pressure? It is also called the intensity of pressure. Pressure also called the intensity of pressure. Pressure can be defined. Pressure at a point is defined as the ratio of force to area. That is pressure P, force upon area. In a simple word, it is force to area, ratio of force to area. This force is acting perpendicular to that surface area at a point where you have to find the pressure. That is the pressure. What is the unit of pressure? Unit of pressure, Newton per meter square. At is the force per unit area. For the force it is Newton, for the area it is meter square. So Newton per meter square. It is also called the Pascal. Newton per meter square is also called the Pascal. So pressure is having the different units like the Newton per meter square or Pascal or kgf per meter square or bar. Different units are there. So in these units, what is the relationship? 1 Newton per meter square is equal to treated as 1 Pascal, and 1 bar is equal to 100 kilopascal. 1 kilopascal 1000 Pascal, and 1 kgf equal to 9.81 Newton. So you can convert from one unit into the another unit. This conversion you have to know. So 1 Newton per meter square, that is 1 Pascal, 1 bar, that is 100 kilopascal, and 1 kgf, this is 1 kgf equal to 9.81 Newton. So this is about the fluid pressure. Next we are going to the Pascal law. Then we will go about the different types of pressure. Pascal law. Pascal law, that is what it states? It states the pressure or intensity of pressure at a point in a static fluid is equal in all direction. The pressure at a point in a static fluid is equal in all direction. The pressure, that is Px equal to Py equal to Pz. Px is the pressure at that point in x direction, Py is the pressure in y direction at that point, and Pz is the pressure in the z direction. That is the pressure at a point is equal in all direction in a static fluid. That is the Pascal law. So from this we will have the P equal to rho gh. That is, you can see dP, if there is a change in the pressure. Let me write it again here. This is dP upon dH, that is equal to rho g. If you know rho g, what is rho g? Rho is into g. That is the, if you remember, weight density. Weight density is what? Weight upon volume. Weight upon volume. Weight is mg, volume is v. Mass upon volume is rho into g. That is weight density. So this change in pressure in the vertical direction is equal to the weight density. So from this, if you integrate, you will get the P equal to rho gh. So main concern here is about the P is the pressure at that point, rho is the density of the fluid, g is the acceleration due to gravity, and h is called the pressure head. H is called the pressure head. Pressure head. H is called the pressure head. So P, pressure at that point, rho is the density of the fluid, g is acceleration due to gravity, h is the pressure head. So from this you will get the pressure or pressure head as depending what is the requirement. So next we are going to discuss about the absolute pressure, about vacuum pressure and gauge pressure and the relation between them. What is this? absolute pressure, vacuum pressure and gauge pressure. Absolute pressure is defined as the pressure which is measured with reference to absolute vacuum pressure. That is absolute pressure, that is the pressure which is measured in reference of the absolute vacuum pressure. If any pressure is measuring in reference of the absolute vacuum pressure, then that pressure is called treated as the absolute pressure. If the reference line is the reference line is the absolute vacuum pressure. If the reference line is absolute vacuum pressure, then the pressure in respect of that reference line, the pressure is treated as the absolute pressure. While vacuum pressure, this is defined as the pressure below the atmospheric pressure. That means in case of the vacuum pressure, reference line is the atmospheric pressure. When you measure the pressure that is below the atmospheric pressure, by taking the atmospheric pressure as a reference line, then that pressure is treated as the or called the vacuum pressure. What is gauge pressure? In the gauge pressure, the pressure which is measured in reference to atmospheric pressure, and it is above the atmospheric pressure. For the vacuum and gauge pressure, the reference line is the atmospheric pressure. For both pressure, reference line is the atmospheric pressure. If the pressure is measuring below the atmospheric pressure, it is called the vacuum pressure. If the pressure is measuring above the atmospheric pressure, it is called the gauge pressure. That is the difference between the vacuum and gauge pressure. Vacuum pressure is below the atmospheric pressure, while gauge pressure is above the atmospheric pressure. Both in these two cases, vacuum pressure and gauge pressure, atmospheric pressure is the reference line. While in case of the absolute pressure, the reference line is the absolute vacuum pressure or absolute pressure also called. That is the absolute pressure you will get in reference of the absolute vacuum pressure. So just again I am defining this one. In case of the vacuum pressure and gauge pressure, reference line is the atmospheric pressure, while in case of the absolute pressure, reference line is the absolute vacuum pressure. You can see in the next slide how we can take the reference line. It is, we can imagine it in a better way. See here, you can see this is the one reference line. Absolute vacuum pressure, that is called the absolute zero pressure. This is also called the absolute vacuum pressure. Absolute vacuum pressure or absolute zero pressure. This is the one reference line. This is the one reference line. This is the one reference line, and this is the second reference line, that is the atmospheric pressure. This is the atmospheric pressure line. This is the line of the absolute zero pressure. Now we are measuring the pressure at a point, this point. This point, suppose this point is called A. This point is called A. We are measuring the pressure at point A. This is the point B. So at A, if you measure the pressure by taking the reference line as the atmospheric pressure, then this pressure at this point is called the gauge pressure. This is from this reference line to up to this point. That is it is for the gauge pressure. How we define the gauge pressure? Gauge pressure is the pressure at a point which is measured in reference of the atmospheric pressure, and it is above the atmospheric pressure. So as this pressure is measured in respect of the atmospheric pressure and it is above the atmospheric pressure, that's why this value is called the gauge pressure. This pressure is called the gauge pressure. While at point B, if you are measuring the pressure with the same reference line as the atmospheric pressure, but this point B is below the atmospheric pressure, so this pressure is treated as the vacuum pressure. Vacuum pressure is the pressure that is measured in respect of the atmospheric pressure, and this is below the atmospheric pressure. This is called the vacuum pressure. These both points A and B are measured in respect of atmospheric pressure, but one is above the atmospheric line, one is below the atmospheric line. The point which is above the atmospheric pressure line, the pressure at that point is called the gauge pressure, and the point which is below the atmospheric pressure line, the pressure at this point is called the vacuum pressure. Now take the reference line, this absolute zero pressure or absolute vacuum pressure. So in reference of this line, if you are measuring the pressure at point A, then it is this is called the absolute pressure, then it is called the absolute pressure. That is the absolute pressure you can see here for this line. This is the absolute pressure for this line, that is it is measuring in respect of the absolute zero pressure. At point B also you can see, if you are measuring the pressure at point B, this is the line you can see, if you are measuring the pressure at point B in reference of this absolute zero pressure, then the pressure is called the absolute pressure at point B. If the reference line is absolute vacuum pressure, that is also called the absolute zero pressure. So now hope it is clear to you what is the absolute pressure. This absolute pressure, this is the relationship you can see, absolute pressure equal to atmospheric pressure, that is this pressure plus this pressure, and this pressure is the atmospheric pressure, this pressure is the gauge pressure. So this atmospheric pressure plus gauge pressure, it will give you the absolute pressure. So that absolute pressure is the sum of the atmospheric pressure and gauge pressure. So this is about the absolute pressure, atmospheric pressure, gauge pressure, vacuum pressure. Atmospheric pressure is taking at the two reference line. Again I am just briefly explaining. Absolute pressure is the one reference line and absolute zero pressure is the second reference line. We can measure the pressure in respect of the atmospheric pressure line, then the pressure will be either gauge pressure or vacuum pressure. If you measure the pressure in respect of the absolute zero pressure line or absolute vacuum pressure line, then the pressure will be treated as the absolute pressure at point A and B both. For the example taken here, you can see vacuum pressure relationship, that is the, if you take the vacuum pressure, then this vacuum pressure is how much? Atmospheric pressure minus absolute pressure. This is the, from here to here, this is the atmospheric pressure. From this line to this line, it is the atmospheric pressure. If you subtract this vacuum pressure, if you subtract this absolute pressure from this atmospheric pressure, if you this is the atmospheric pressure, this is atmospheric pressure. If you subtract this absolute pressure for the point B, absolute pressure, you will get the vacuum pressure at point B. That is the relationship between these three pressure, that is the absolute pressure, gauge pressure, vacuum pressure is depending upon the reference line, which reference line is taking, accordingly pressure will be, you can measure the pressure accordingly. So this is for the today class. We will discuss the pressure head in the next session. Thank you.